Welcome to this explainer, everyone. Today, we have a really special session tailored specifically for all you grade 7 learners out there who are stepping into the amazing world of chemistry. But hey, we aren't going to treat this like some boring textbook topic. No way. Today, we're unlocking a secret. We're going to look at the science of the perfect mix. By the time we finish up here, you're going to understand exactly how the math you learn in the classroom perfectly predicts the things you experience every single day.
So let's dive right in by asking a question I am absolutely sure we've all faced at some point in the kitchen. Have you ever poured yourself a nice tall glass of juice, taken a big sip, and realized it tasted way too watery? Or maybe the exact opposite happened, and you added so much powder that it was practically syrup. Normally we just rely on our taste buds, right? Maybe splashing in more water or scooping in extra powder. But there's actual precise science happening right there in that glass.
Honestly, think about all the things we mix on a daily basis. Sugar being stirred into your tea, a salt shaker pouring into a pot of water, or emptying out a packet of juice powder. These aren't just snacks or drinks. To a scientist, these are active chemistry experiments happening right on your kitchen counter.
In science, we actually call these everyday mixtures solutions. A solution happens when you take a solid substance and dissolve it completely into a liquid. So, these everyday examples, your sugar water, your salt water, your morning juice, they are the absolute perfect starting point for understanding how chemists measure exactly what's floating around inside our glass.
All right, let's get into section 1, defining mass concentration.
To figure out exactly why that juice was watery or why that tea was way too sweet, we need to learn a specific scientific term. Now, I know the official definition looks like a total mouthful, expressing quantitatively the mass of solute present in a given volume of solution. But grade 7s, do not let those big words scare you. Let's just break it down together. Quantitatively literally just means we're using numbers. The solute is the fancy science word for the stuff you're mixing in, like your salt, your sugar, or your juice powder. And the volume of solution is simply the total amount of liquid you have in your container.
So the absolutely crucial point here is that mass concentration is just a measurement. It's a handy way of using numbers to tell us exactly how much powder is currently floating around dissolved in our water. It takes the guesswork completely out of the equation. Instead of just saying, this tastes a bit weak, mass concentration gives us the exact mathematical profile of that drink.
Moving right along to section 2, the magic formula.
Once you know this formula, you basically have the superpower to analyze any mixture in the world. Here's the full word formula. To find the mass concentration, you just take the mass of your stuff, your solute, and you divide it by the volume of your total liquid, your solution. That's it. It's a really simple division problem. Mass on top, volume on the bottom.
But let's be honest, scientists love shortcuts. We definitely don't want to write out mass concentration and volume of solution every single time we do a math problem. So we use a letter code. We just use the letters C, M, and V to make the formula super quick and easy to write down. Big C stands for our target, which is mass concentration. Little m is for the mass of the solute, and big V is for the volume of the solution. C equals m divided by V. Say it with me in your head. C equals m over V. That is your golden key for this entire topic.
Now, when you actually do the math, your answer needs a label. A number all by itself doesn't tell us much in science. Depending on how much liquid you're working with, your answer will look like one of these common units. You might see G/ml, which simply means grams of solute per milliliter of solution. If you're mixing a giant bucket, you might use G/L for grams per liter. And sometimes you'll see a percentage sign with an M over V in brackets, which is just a special way of saying how many grams are in exactly 100 milliliters of solution. Basically, these units are just telling you how many grams of powder are hiding inside a specific amount of water.
Which brings us to section 3, concentrated versus dilute.
Now that we've got our formula and our units all sorted out, let's talk about the visual difference between a drink that packs a serious punch and one that's super weak. If you have two containers with the exact same volume of liquid, meaning the water line is at the exact same height, the difference is all about what's inside. A concentrated solution is packed with a ton of solute. A dilute solution, kind of like that watery juice from earlier, hardly has any solute in that same amount of liquid. So more stuff equals more concentrated. Less stuff equals dilute.
All right, section 4, let's do the math.
Okay, grade 7s, grab your mental calculators or a piece of scratch paper if you have one handy, because we're going to do a real-world lab example together right now. We're going to put that C equals M over V formula to the test.
Here's our scenario. Imagine we take a spoon and dissolve exactly 10 grams of salt into 200 milliliters of water. Step 1, we identify the mass of our solute. That's the salt, so our M is 10 grams. Step 2, we identify the volume of our solution. That's our liquid, so our V is 200 milliliters. Step 3, we just plug those numbers into our formula, C equals 10 divided by 200. When we do that math, we discover our mass concentration is exactly 0.05 grams per milliliter. It is really that straightforward.
So now it's your turn to be the scientist. It's time for a little challenge to test out your newly found chemistry skills.
Here's the setup. You have 15 grams of sugar, and you're dissolving it to make a total of 500 milliliters of solution. I want to know, what is the mass concentration in grams per milliliter? Think about our magic formula. C equals M divided by V. Identify your M, identify your V, and try to calculate the concentration of this sweet sugar water right now in your head before I reveal the answer. I'll give you a second. 15 divided by 500.
Okay, let's see how you did. If you took your mass, which was 15 grams, and divided it by your volume, which was 500 milliliters, you nailed it. The correct answer is 0.03 grams per milliliter. Give yourself a massive pat on the back if you got that right. You are officially calculating chemistry equations.
As we wrap up our analysis, I want you to lock this final golden rule into your brain. A higher mass concentration means more solute in a given amount of solution. The higher that final decimal number is, the more heavily packed with solute your solution is. The lower the number, the more watery and dilute it is.
So, I want to leave you with this thought. Next time you're in the kitchen, ripping open a packet of juice powder or sweetening your morning tea, think about the mass and the volume. Because now you know that chemistry isn't just a subject in a textbook, it's the hidden math inside your glass. Can you calculate exactly how concentrated your next drink is before you even take a single sip? Keep wondering, keep calculating, and keep exploring the amazing science right in front of you. Thanks for joining me on this explainer, and I will catch you on the next one.